And how do you think about interoperability as well with the existing blockchain worlds, protocols, all of that stuff? Is it going to be an interoperable world essentially, so people can use existing piece of the Lego and build it, then rebuild it or reimagine it on top of your own stack? I mean, how do you think about that?
Well, first of all, I think there will be a small number of leading blockchains. I don't think there are going to be thousands of blockchains. And the reason is pretty simple. If everyone's, for example, building on the internet computer, then in one seamless universe, then you need to build inside that same seamless universe to benefit from the zero cost of interoperation that universe provides. So you're going to get better network effects there. And ultimately, if it's faster and cheaper and has, supports better smart contract software development frameworks, we call them canisters. Why would you want to build on some other chain? It wouldn't make any sense. So, network effects will drive massive consolidation. It's true. The reason that different kinds of blockchain will remain is that they'll address different niches. So, Bitcoin is playing the role of digital gold very successfully. Ethereum, might appear competitive, but really Ethereum and the internet computer are very different things. And I think Ethereum will become a DeFi settlement layer. And there are differences between Ethereum and the internet computer. So, for example, anybody can run an Ethereum node. That means that you could configure a computer for mining Ethereum, and you could run it from your office, under the desk, say, right? And you could be a completely anonymous participant in that network. The challenge with that architecture is that you end up with very large amounts of replication, and this drives costs up. So the internet computer works a bit differently. It's actually controlled by a governance system that runs within the network as part of the network called the network nervous system. The governance system is completely open and permissionless, and anybody can submit proposals to it. And it decides whether to adopt or reject the proposals that are submitted. And if it adopts a proposal, it executes it automatically. Now, part of the purpose of the network nervous system is to induct these special node machines, which are standardized, and combine them into these things called subnet blockchains, which increase the capacity of the network. Now, the network nervous system needs to know who is running these different node machines and where they're located in order to create these subnet blockchains in a secure way. So when it wants to create a new subnet blockchain, it combines node machines from around the world that are independent. And it does that by looking at a decentralization hierarchy, which is node provider, i.e. who owns and operates the node, data center, i.e. in which data center is the node installed and where's it running from, geography, and of course, that matters. I mean, we talked about withstanding a nuclear strike. There are many things that can destroy a data center. For example, you can get a solar flare from the sun, which sends out an electromagnetic pulse. So, we want to make sure that the node machines are not only in different data centers, but those data centers have a certain amount of geographical distance between them. And then lastly, jurisdiction. You can imagine that if, for example, all the node machines were in data centers in different countries in Europe, a potential risk would be that the EU enacted some kind of legislation. So, the network nervous system configures and builds out the network, and it creates new subnet blockchains to increase its capacity by combining these node machines from independent node providers in independent data centers, and it looks at geographical dispersal and jurisdiction. So in the internet computer model, node providers, the people running and who own and operate these node machines, aren't anonymous, and so that's quite a big difference between the internet computer and Ethereum. And the reason the internet computer works that way is it enables it to get high levels of security with much lower levels of replication. And of course, that's essential to driving down the cost of the network. So, we want the internet computer blockchain to host systems and services at costs approaching or even below legacy IT.